Okay, we're now going to start factoring polynomials, trinomials here that have a coefficient in front of the x squared term. If you look at number 1, that doesn't look like something you've seen yet. Or maybe you have, and you're confused, and that's why you're in here. But the 3 in front of x squared plus 10x plus 7, the 3 in the front is a coefficient other than 1. And in number 2 here, you have 2x squared is another coefficient other than 1. So these are the red flags here. Remember when you were factoring in the previous worksheets, you would just automatically write an x and an x. Well, that's not the case anymore. Because if you guys remember, the first two terms here and here, they have to multiply to this guy. So it's not just x and x any longer, because x times x is x squared. What do we need? We need 3x squared. So let's figure this out. How can we factor this? Well, it's tricky. And I wish there was just an easy way to teach you this, but there's just not. So what we're going to end up doing is we're going to do trial and error. I think that's just the safest way to universally teach how to factor something like this. So let's go through this. What am I talking about? Well, let's list out all the factors of 3. 1 and 3. And then let's list out all the factors of 7. 1 and 7. So thinking now of our parentheses, we know one thing. We know that the outside terms and the inside terms better equal a positive 10x. So we need to play a number game. How can I arrange 1 and 3 and 1 and 7 in these 4 different spots to get plus 10x? So let's take a look. Let's just guess. What if I put 1 and 3 just like they are right here? 1x and 3x. Remember, why do I have the x's there? Well, they have to equal 3x squared. So 1x times 3x is 3x squared. We're okay there. But now, there's no other options, right? We could switch them around, but because these are the first terms that we use, we're just going to plot them in there. You could have written 3x and 1x. That's fine too. And now it all depends on where we're going to place 1 and 7. So let's just try it. Let's put 1 here and 7 here. Okay, and let's just see what happens. We have 1x on the outside times 7, that's 7x. And then 1 times 3 is 3x. Hey, wait a minute, look at that. We potentially could get 10x out of that. If what? If we gave plus signs to both of these, that gives me that 10x is what I'm looking for right here in the middle. So take a look. In our first trial and error, it worked out just fine. That will rarely be the case because you'll have to use an eraser and you'll end up erasing a lot of this, but that's fine. Sometimes you will get lucky. Okay, let's try another one. Number 2. Starting off again. It's different. It's a different type of problem. But that's okay. My factors of 2 are 1 and 2, and my factors of 1 are 1 and 1. So let's go ahead and list them out. This time I'm going to put the 2 here. I'm going to put 2x and 1x. Okay, and my only options are 1 and 1. Okay, so let's test it. The outside terms, inside term. Somehow I need a negative 3. What sign do I have to give 2x and x, 2x and x to get negative 3? You guessed it, 2 negatives. That gives me negative 3x. That's exactly what I'm looking for. So boom and boom. And you're done. It's hard, it's tricky, but the procedure stays true for all these example problems. Alright, number 3, then we'll get started on some practice problems. Listing out, let's do a different color here. Let's list out all the factors of 2. Well, 1 and 2, and 1 and 1. So here we go. Here we go in the black. We have 2x and x, 1x. And we have 1 and 1. We know that the outside terms must equal 2x and the inside terms 1x. But what do we need? Let's see. We need a negative 1 in the middle. So I need to set this equal to negative 1x. Well, what signs do I have to give 2x and x to receive that negative 1x? A negative 2x and a positive 1x. That's the only way I can do it. So what you will see, or in trying to do here, is you will take your 2x and 1x on the outside, and you'll give that a negative because that would result in a negative 2x. And now your inside term here, 1x and x, you want it to be positive, so you will put your plus sign here. And ultimately, when all else fails here, guys, you could always redistribute this out. You can multiply these polynomials out, and if it comes back to the original polynomial that you started with, the original trinomial, then you're golden. All right? Good.